Okay, so today we're going to talk about projectile motion, and we're going to just assume that almost everything we do is just thrown straight up in the air. Why? Because if you add this horizontal component, it gets real confusing real fast. And we have to use trigonometry, which you don't know yet. So, oh, I love when I click on things the wrong way. Okay, so when an object is dropped from a certain height, gravity causes it to fall at a certain rate. It's magical. It's like gravity follows a function or something. It does. It really does. So when an object is thrown, there's an extra force involved that works either with or against gravity, but gravity always wins. Over time, gravity wins. So this extra force is called initial velocity. We use v naught, or v with a little zero, to represent it. It basically means starting velocity. Okay, that's what it's called. So v naught is positive if the object is thrown upwards. It's negative if it's thrown downwards, because gravity is considered a negative force. So when we throw against gravity, it would be positive. If we throw with gravity, it would be negative. All right, so a couple things to note. This is the force of gravity. It's affecting you at time squared. This is the initial velocity. This is the starting height. T is time in seconds, but it could be time. So T is time in seconds. If you want to do time in any other component, you have to change this number, because gravity affects you differently if you're not moving in seconds. Instead, you're looking at minutes or whatever it is. This is the final height, or where you ended up after t seconds. Okay, eventually you'll hit the ground and it'll give you a negative height. You know that that doesn't make sense, so you won't go there. It's very exciting. Okay, so here's an example. A baton twirler is tossing a baton into the air. The baton leaves the twirler's hand 6 feet from the ground and has an initial velocity of 45 feet per second. The twirler catches the baton when it falls back to the ground at a height of 5 feet. For how long is the baton in the air? Okay, so basically this looks like this. It leaves her hand here, goes up, and it comes straight back down, pretend that's straight back down, and lands about here. How long did that take? Okay, that's what we're wondering. So we need to identify a bunch of things. First thing, starting height. What's our starting height? 6 feet. Okay, what's our initial velocity or starting speed? 45 feet per second. That's important to know. Okay, and then gravity, we already know. And I think that's all the information we need to get started. So gravity, so we want to know our final height. We actually know that. Ooh, that's the other one we know. Our final height is 5 feet. Okay, so now we can set up our equation. So we know our final height is 5 feet equals, here's our negative 16 from gravity, t squared. Then we have to add our 45 feet per second with a t, and then add the 6. Because we started 6 feet above the ground, it wasn't 6 feet below the ground. Okay, so now we want to solve for how long this takes. Well, the easiest way to solve is first set it equal to 0. So I'm going to subtract 5 from both sides. And we get 0 equals negative 16 t squared plus 45t plus 1. Now I'm going to use the quadratic formula, because why not? And we're going to get 2 answers. One will make sense, because it'll be a positive time. The other one won't, because it will be a negative time. If they're both positive times, then it's possible. For both, then that doesn't make sense. So, because we threw it at 6 feet, right? We didn't start at 5 feet. We threw it at 6 feet. It's above 5 feet. So we need to solve for t. So we're going to find a, b, and c. So a is negative 16. B is 45. And c is 1 in our equation with the 0, right? Okay. And then we're going to find the discriminant. So we're going to do 45 squared minus 4 times negative 16 times 1. So we do 45 squared minus 4 parenthesis negative 16 parenthesis 1 close parenthesis enter. We get 2089. Okay, so then our quadratic formula. You ready to sing our song? Except it's going to be t equals instead of x equals. T equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so we have to do this twice. Now, if you were in class, I've already shown you how to do this. If you weren't in class, maybe not. So I do alpha y equals enter, and it creates this cute little fraction thing. So then I'm going to put the negative 45, and I'm going to start with plus square root. I'm just going to grab that number. And then divided by 2 times negative 16. So 2 parentheses negative 16, close parentheses, enter. And I get negative seconds. That doesn't make sense. So I'm going to go change it to minus. So I go grab the equation. I come over here to the plus sign, change it to a minus sign, hit enter. And it's about 2.83 seconds that it's in the air. Okay. So now you guys are going to do something similar. So it says in a volleyball game, a player on one team spikes the ball over the net when a ball is 3 meters above the court. The spike drives the ball downward with an initial velocity of 10 meters per second. Players on the opposing team must hit the ball back over the net before the ball touches the court. So how much time from when they hit it to when it falls do they have? I just realized this is not in feet. Hold on. We're going to change that to 3 feet above the ground. And it's followed, and they hit it with 10 feet per second. Okay, beautiful. Much better. Okay, so now you can do this problem. Ready,